Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder from Nat King Code, coming to you live from the Mile High City of Denver, Colorado. I have two awesome guests joining me tonight. We have Mr. David Englehart, and we have Bryce Nesbit. I'll let each of you gentlemen introduce yourselves and kind of go over we could pretty much talk about anything we want, but I thought we'd probably talk about electric vehicle service equipment tonight.
Well, I don't know. I guess I can start. Um,
Okay.
Honestly, when I was a kid through high school, I started like worse than Mel Tillis. I don't know if you all heard of Mel Tillis before.
No.
Hello,
I haven't heard of that.
have not heard of Mel Tillis, the country singer?
No,
No.
no.
Oh my goodness. Oh well.
Yeah, I'm a youngin.
So this it's anyways. So I became an electrician after I couldn't find any nails to pound for 3 months. I pounded nails right out of high school, uh, building houses,
Okay,
until I couldn't find more nails to pound back in '86, and that's when I became an
nice.
electrician. And that's and ever since I became an electrician, have not had to look for a job since. Knock
Nice.
on wood.
There you go.
So
Yeah, and it's really awesome. I was in sixth grade in '86, so that goes to show you I'm a youngin. I'm still a little getting up there though. My son actually asked me one day what 1900s was like.
yeah, I
So
graduated high school in '79. Right out of high school, I started went to work for a home builder that was building a house for my dad next door to
okay,
where we lived, and then yeah, um, shot a T-nail perfectly through this joint right here one Saturday
wow,
morning, and then yeah, let me see, yeah, that was the first job I got fired from. I was still 17 also. That nail to my finger there
ouch,
was a workman's comp deal that
oh wow.
I don't know whatever happened with that, but I went to high school and whatnot. Or
That's
yeah,
that's like back in the days where if you fall off the ladder, you're fired before you hit the ground.
yeah, that was still in '79,
All right.
and then after I got fired, the last the last straw was, well, in the middle of that, I forgot to take a chipping hammer back to the rental place one Friday afternoon after using it for a job.
Okay.
And then the last straw was we were out forming a slab and sent the boss out for the steel, and I forgot that we needed the visqueen first before we laid the steel down. So he got back with the
Oh,
steel and said, "Oh, forgot about the visqueen, boss." So he said, "Dave, you're fired. Get the hell out of here."
oh man. Well, getting over to Bryce, I've been talking with you a little bit, messaging you over on the Mike Holt forum, and very interested to hear kind of your take. I think you have a little bit different angle, kind of than what me and David Englehart are a little bit of code nerds. We're always getting in with the electric code, so it's going to be interesting to kind of see your take on these things. And why don't you just kind of introduce yourself and give us some background on you?
Yeah, I'll be happy to share. I've been various kinds of nerd, and recently I've been a code nerd, which is kind of weird because it's
Hmm.
not really my background. I've been on the design side. I did search for my first job, but I knew what it was, and I got recruited into it. And then I haven't searched for another job either because kind of new things come and I roll into them. So a while ago, I volunteered for this group called EV Charging for All, which is trying to
Okay.
make it more practical for people who are apartment renters to
Okay.
charge an EV should they choose to drive one. And that's turned
Gotcha.
into starting a new company. And now we're into some code issues with the NFPA 70, the electric code, that there'll be a final vote in Las Vegas on the 19th, and some things
Okay.
working particularly well for the EV charging industry's ability to innovate.
Nice.
So I got some
Well,
slides.
as you know, I actually submitted a public input that passed for 62554, and I
Awesome.
submitted it kind of as a joke, and it passed. So I was really surprised that it passed, and I basically I was kind of I didn't really I kind of wanted it to go either way. Like basically, if it was rejected, then the protection's really only required for the receptacles. If it passed, then it proves that the outlet's installed, and it says outlets installed for connection to EBSE. So I have some audio to kind of give you a little bit of background on this, and so I kind of want you to listen to this and kind of see our angle from where this has kind of been presented based on a code change for 2020 210.8F. So here, I'll play this audio. I could stop at any time. Like if there's something you want to talk about, just tell me to stop and I'll stop the audio.
If equipment in these locations gets replaced, then the outlet for the equipment must be GFCI protected. Okay, now I'm showing a pretty substantial electric vehicle supply equipment here. Probably not one that you have at your house, but this requirement does apply to multifamily dwellings as well, doesn't it? So if that electric vehicle supply equipment is 150 volts to ground or less, and 60 amps or 50, I think it was 50 amps or less, then these would need to be GFCI protected. Now there's two exceptions. The first one is for lighting outlets. Lighting outlets do not require GFCI protection. Receptacle outlets already do. Lighting outlets do not. Where's the outlet for that? Well, it's where the NM cable meets the luminaire, right? That's the lighting outlet. When we have hardwired equipment, utilization equipment, it is an outlet point, right? So where the wires hit that luminaire, that's the outlet. More specifically, we call it a lighting outlet. Read Article 100. Lighting outlets, those are outlets, but they're not required to have GFCI protection because this exception says they're not. Number two, GFCI protection is not required for listed HVAC equipment until September 1st of 2026. Again, where those conductors leave the disconnect and terminate to the unit, that's an outlet point. If it wasn't an outlet point, we wouldn't have added an exception here to remove it from the code. So that's an outlet. But the Standards Council ultimately, now the Standards Council is kind of like the Supreme Court over all of NFPA. Okay, you have the code making panels, then you have the correlating committee that's above the entire code. Well, above the correlating committee is the Standards Council. It's like the code making panel is the court, right? The judge, and they pass down their sentence. You can appeal that, right? You can appeal that, and you can go to the appellate court. And if they shut you down and it's a constitutional issue, you can go to the Supreme Court, right? Well, the Standards Council is kind of like the Supreme Court. The Supreme Court of NFPA, the Standards Council, they handed this down. And they said, listen, this is a problem. We are going to have an exception for outdoor outlets at air conditioners.
So just to kind of give you background on this, I did send you the copy of the story of this. It was a 12-year-old boy that got electrocuted in Chicago. That was the basis of this. And it was kind of interesting because they actually used that as a substantiation to add 210.8F to the code, but they didn't actually mention anything about this death or anything until it went to the Standards Council. And the Standards Council, they did actual testing on the units and found out that there was a lot of incompatibility issues, and that's when they actually issued the exception. So pretty interesting. I'll keep going.
Yeah, it's interesting. It's also interesting that the thing that triggered the rule was then immediately accepted. It was immediately the subject of an exception. Everybody else got to deal with the rule, except for the one case.
And,
True.
And I'm sure I put my input in on this before on this podcast or whatnot, but the reason why AC units will not are not compatible with GFCI protection 4 to 6 milliamps is what I understand is that the AC unit, the standard for the AC unit allows up to 10 milliamps of current to flow on the equipment grounding conductor.
That's correct.
With that, of course, obviously, the GFCI protection is not going to hold. So, they
True.
need to fix the standard, or require. Fix the standard, and require a grounded neutral conductor to the unit,
True.
so that they can use so that they have a proper, just like when they required it for switches. Okay, when in 404, when they required a neutral conductor at switches, for the same reason. So
so just so you have the background, Bryce, they did have some of these like energy management switches that actually use the equipment ground as like a return path, and it wasn't carrying much, but it was enough to actually bleed current onto the equipment grounding conductor. And so they actually did a code change, and they made it to where if you use those switches, you have to have a neutral conductor. And I do agree with that, David. And that's not the only problem though. They actually, a lot of these units, they use like power conversion equipment. They use variable speed drives. And when you use these freak drives, I call them freak drives, it makes a unit more efficient. It's essentially a dimmer for your motor. But the problem is that when that Class A device sees that leakage current, it thinks something's wrong and it trips. And so what the real problem was they actually started killing elderly people when they first implemented this and started getting it onto like places like Nevada and Texas. Texas was a big problem, I heard, but like Texas, Nevada, New Mexico, places like that, they actually had problems with these elderly not being able to reset their breaker. So that's why they decided to go with that window that you heard of the September 1st, 2026. Me and King James are actually thinking that that's a little bit ambitious, that if they're going to get them all compatible by then. But we'll keep going with this audio. It's just kind of relevant, and it's funny because these were actually the individuals that you were talking with at the second draft on Thomas Dimitrovich's live show. So I'm just kind of showing you their point of view, and it was just funny kind of seeing like they'd already done podcasts on this. So I'm just going to kind of show their audio so you kind of have context. And this is a real short, and it's almost over.
Until September of 2026. So there you go. We knew it was going to be a big topic. Look, man, it's GFCIs. It's always going to be a big topic. So there you go. Hope you got something out of this, and we'll see you on the next video.
That's a familiar voice.
Yeah, so that's Ryan Jackson.
Yeah. So electrically, from the electrical engineering point of view, I can explain a bit more about why the GFCI devices are tripping. And it's often the AC to DC conversion. And we now have not just HVAC units that are using direct current motors, but range hood fans, and really any sort of fan turns out to have better speed control and better power efficiency if you first convert AC to DC and then actually just have a DC motor.
Question, what about pool heat pumps? Same thing?
Well, the exact same thing. If the motor itself, the compressor motor, is one of these linear motors, or a more modern motor, then it can have these sort of unimportant transients. And in the EV charging world, the problem goes up with the amperage. So you may be able to charge your Chevy Bolt at 24 amps without tripping your GFCI, but bring in a school bus or a megawatt charging system with a giant semi, and you're talking about a megawatt here and 5 milliamps over here.
Yeah, but
it just doesn't work.
Yeah, but the thing about that is, though, are those still going to be required to be GFCI protected per 210.8? Or, let me see, what is it, 6?
It's
Oh,
62554 is the new one that they're
625,
gonna
yeah.
cover. So 62554 was proposed by UL to be deleted completely and just do 100% up to 10.8, but that got rejected. So they very forcefully said that it's gonna stay in 62554. I actually Bryce probably knows more about it than I do. He's in all the meetings and stuff, but that's why I'm really glad to have you on here because kind of one of the things that David was talking about was that there is no listing standard for EBSE, which I think is incorrect. And I believe that when you look at the listing standard for EBSE, and I thought you brought this up, I thought I heard you say this in one of the broadcasts, that even the cheap knockoffs are copying that internal personnel protection. So even if it was a unit that's like some cheap thing from from China, they're copying a design that's compliant with the National Electric Code. I believe it's 62522 would be the standard for that, correct?
So there is a UL standard for EVSE, absolutely. And the elephant in the room for all of our code discussions, or the elephant not in the room, is unlicensed handyman work.
True.
And crap on Amazon that is sold with no safety standards whatsoever. True. Or even crap on Amazon that claims that it's UL listed, but they list the wrong standard, or they just out and out fake it.
Yeah.
True.
Yeah.
So
Correct.
that's a problem. But it so turns out that there is an open source design for EVSE called Open EVSE that is not itself UL listed, but it's a kit from which you can put together an EVSE pretty cheaply. And a lot of those Chinese things just have that because it was the cheapest thing for them to do. So it may meet all those standards, but they haven't actually tested it to those standards. And of course, they change their company names every week. So when you're ever buying something,
John in the house. Thanks for joining, John. Sorry to interrupt.
So if you're buying something on Amazon and the name is a couple of random words stuck together, you can be pretty sure that there's no warranty service. No one's going to stand behind it if it turns out to be bad. If we were looking for the greatest amount of safety for the least amount of work, cracking down and insisting that Amazon actually check the listing standards of the electrical equipment they sell, I would say would be an excellent start.
And you know, this stuff, be prepared for a fire too. You know, with the stuff that's going out without being certified by a listing standard by a NERDL. I mean, let me see, what is that that biggie that's the biggie that some people put on their stuff. That's a self-certification or whatnot, but it is certified. But let's see, what was I getting to? The stuff that's not certified, that has fraudulent listing information and stuff like that. I mean, that's just the fire looking for a place to happen. So
yeah, and I could tell that Bryce kind of had his ears perk up when I started talking to him about I've heard, and it's just a rumor that I've heard, that the dealerships tell you not to park your EV in your garage just in case it catches on fire. And I think you were saying that's a myth.
Well, actually, there have been several EV and gas car recalls recently in the past couple of years where the cars spontaneously caught fire.
Okay.
And those manufacturers said, until we fix this problem for you, you shouldn't park it in the garage.
Okay.
But this is a specific flaw that went through a recall process. The Chevy Bolt was one of those cars. That's the car that I have parked outside of my garage right now, but that's because my garage is full of junk.
Right.
So yeah, that's happened. Both gas cars and electric cars can catch fire. The statistics show that the electrics are catching fire less, but they're also newer, so it's a little hard to work out which is which. The difference is that it's a lot harder to put out an electric fire, but that could change. So it took fire departments some decades in order to really figure out how to deal with gas car fires, and they haven't had quite as long with EVs. But one of the things that's used is the fire department carries a giant blanket, and they just throw that blanket over the burning vehicle and deny it oxygen. And that gets the temperature down and lets them get ahead of the fire. If they just put water on it, they're going to be using 10,000 gallons of water and not really put it out.
Correct.
And then there's this cool thing called XLith. If I can share screen in a moment, I'll show you XLith. And XLith is an additive.
I think if you just go down to the bottom, it has a screen share option.
Yeah.
On the bottom.
I think it says present there.
Yep, we'll get it.
Present.
I got it. And hello. Here we go. And so XLith is a
I can actually put I could change the layout to like this, I think. And then when you share your screen, it'll come up on that.
Okay, so it says it's sharing from my side. I don't see it on the podcast yet.
Let me see if
There we go.
is that it?
Nope.
Or let me see.
Employment eligibility verification.
Department of Homeland Security. Well, you know,
Okay. All
can't be too
right.
careful these days.
True that.
All right, let's see. Oh, okay. I'm sorry, I'm on the wrong thing. Let me see.
So I'll talk through XLith while you're working on that. So XLith is an additive to water that binds to lithium. And so if you pump a little bit of XLith into your firefighting water, suddenly it'll put out a lithium fire. So this is being sold in the form of fire extinguishers and an additive for fire trucks. So if I were a freeway service patrol of some sort that was doing firefighting on an interstate highway, I'd be wanting to look this stuff up.
Okay, that should be it.
There we
Sorry
go.
about that. I'm kind of new to this. I'm looking in our old files and I was looking in the wrong place. Sorry about that.
So XLith LLC, extinguishing lithium-ion battery fires. And there's a lot of lithium batteries in laptops and anything. So you could be really interested in this if you were doing airplanes or whatever. And this particular material is not particularly toxic, but it comes in barrels and gets mixed into the sprinkler water. So let's say you had a parking garage. Some of the mechanical access parking garages now, where the vehicles go on tracks, they have a special room for putting out a fire in a vehicle. Again, doesn't matter whether it's gas or electric. They want to take that vehicle and isolate it and then do something to it. And they could do this particular chemical material.
Okay.
So,
Well, if the vehicle's on fire, how do they move it?
if it's in a mechanical access parking garage, it's already on a sled, so they can move the car.
Interesting.
Oh, okay. I see and so then that is almost kind of like a clamshell.
Well, this is in a big building where you drive in and the thing grabs your car and stores it back in the back of the building.
Oh.
So then,
We're talking-
let's say,
We're talking parking garage in New York City, no doubt.
yeah. So you're not going to use this in Iowa, but if you've got maybe Iowa City, but if you've got a parking garage and you've got sprinklers, and you can put some XLith into the sprinkler water, then if you get a parking garage fire, you've got a much better chance of that fire going out.
Okay.
So I think that the fire issue is really real and needs to be treated very seriously, but it's also early enough. The technology is moving forward to better deal with these hazards. Again, the EVs don't catch fire as often, but they burn hotter and longer.
All right. Yes, that's awesome, Bryce. So yeah, I've never heard of that. I don't think David has either. That's pretty
No,
interesting.
no.
So that's
And I'm a
almost
fire safety inspector also.
so that's kind of like in addition to your wet system. Like if you have like a wet sprinkler system.
It's an additive.
Additive
So
to,
it gets
yeah,
mixed, I think, 10% X-lith and 90% water.
Gotcha. Okay. So
And then there's
kinda
another
wanted-
issue that's relevant to the NEC and the code issues
Okay.
and firefighter concern. So the way an EVSE works is an EVSE is just like a GFCI. It's the same things that are in a GFCI with one extra trick. So it asks the car, it sends out a message to the vehicle saying, hey, this is how much current I can supply. And then the vehicle comes back and says, go ahead and turn on. And when those two things happen, it then turns on. But the moment that a vehicle catches fire, its battery will no longer be in spec, and its battery controller will release the control pilot line and actually turn off the EVSE. So if you were approaching a burning EV and you were worried about the charging current, you're worrying about the wrong thing. Worry about the chemical fire that you've got in your hand. You got plenty to worry about. Your EVSE is already off.
Correct. The one thing that David asked, which I thought was really cool on, I think it was like our last podcast, was that the GFCI protection is only for the output. But if I remember correctly, when I read about that standard, it says that it must have personnel protection for the input and output of the EVSE, if that's correct.
So the personnel protection that's built into the UL standard does refer to the EVSE downstream towards the vehicle. But we don't normally protect from equipment upstream. That's not the only place that you can put GFCI protection in. So if you've got a screwdriver and you start removing cover plates in your home or commercial office, you're going to encounter unprotected circuits. So we're kind of used to that. That the GFCI protection, the personnel protection that's baked into an EVSE is at the 20 milliamp level, and it's at that cable downstream. And it has the additional characteristics of it defaults to off, and it turns off if anything goes wrong with that charging process. And it has one more trick in that it verifies the integrity of the ground. So in that Chicago Tribune case where the kid jumped over the fence and landed on the HVAC unit, we don't know because the article doesn't tell us, but most likely that enclosure from the HVAC unit was made of metal and it wasn't properly grounded. And that can't happen with an EVSE. So that EVSE will not start unless that ground has integrity.
Yeah, so you're 100% correct. So what they did was it was about a 20-foot piece of seal tight, and they used the seal tight as an equipment ground. So everything that they did in that case was a code violation. So I think that's where I kind of had problems with them adding it to the code, because they took a code violation and then passed this based on a code violation to change the code. And the thing is, they're like, well, if there was a GFCI on this kid would still be alive, but if there was a full-size equipment ground, the kid would still be alive. So I like that that you brought up that point about the equipment grounding conductor. The other thing I wanted to kind of address too is, how does the reverse backfed, like how does that work? Because I know there's like a lot of confusion on. I know you were one of the people that were talking about this. I really liked what you were saying about the reverse power fed backfed. So you're saying if you put them on a Class A device and you try to like reverse power feed them, then it'll like adversely affect the Class A device that's upstream. And I think that's why you were saying that it was a bad idea to put these Class A devices on them.
No, I think the Class A device is bad for some other reasons, but an EVSE is just a relay with
Okay.
some control logic, and a GFCI is just a relay with some control logic. And if the GFCI is closed or operating
Yeah, close.
and the EVSE is closed, then power is simply going straight from your panel to your car, AC, 240 volts or 120 volts. No processing
Right.
is being done. So that
Okay.
power, in theory, could flow in either direction. If your car raised the voltage enough to cause the current to flow in reverse, the electrons don't know, and it would work just like a balcony solar system or an inverter. So there's nothing inherent about GFCI that makes them incompatible with bidirectional flow. But it turns out that there are a couple of GFCIs on the market now that in testing, when put under a reverse flow situation, melted. And I'd say that those need to get off the market right quick.
Yeah. Okay. So inherently, we could have the code actually pushing some things that could be a little bit of a hazard, possibly. If people are starting to think you have to put these devices on there and actually counterproductive to us making things safer, I guess.
So
Would be my
there's
point.
this movement in Europe. Now there are millions of people who live in apartments who have installed solar on their balconies or in their backyards. And so they just go down to their local big box retailer in Europe and purchase a kit and hang it. Again, that's something I could share visually for people, but
Okay.
that in Europe requires no notification of the utility at the moment. In Germany, you have to fill out a form. It takes about 15, 20 seconds. You just say what model number and when you plugged it in, and then you've registered with the utility. In the US, though, that has not been legal. So it is not legal for you to backfeed in the manner that we're describing and the one that melted the GFCI. That's not even legal in the US. There's only one state in the union, and it's only just about a month ago that passed a requirement that says that balcony solar should be allowed. So we are way far away from any vehicle actually doing this without referencing a different UL standard. NEMA just released about a week or two ago their bidirectional power standard. And
Okay.
yeah, if things go like this, it'll have to be paired with a compatible bidirectional GFCI or no GFCI at all.
Right. And I think the one thing that I thought was interesting is they were talking about the high frequency GFCI in the 2026, and there was actual language in 62554 that permits you to use a GFPE or a high frequency GFCI. And from what I understand, there's not even any high frequency GFCIs that have been released or even tested. I hear it's invented, but to me, guess I have a hard time with them putting that in the code as like an option when it could be really expensive and it's not even really tested or available on the market when the code's going to be released. So I don't know if you saw any of that yet.
Yeah, there's an idea that you could have a smarter GFCI that understands that certain transients aren't as important to safety as other transients and tries to be smarter. Absolutely. I have an argument that there's a better way than even that. But I finally got
Okay.
that Bright Saber picture up. So this is a California company that
Okay.
is creating a way for apartment residents to put a solar panel in and then plug it into a regular electrical outlet and do bidirectional solar. And their biggest
Okay.
challenge is the code. In Germany, balcony solar is common.
Right.
And there was a big Wired story on that not so long ago. But there are some just random pictures from Germany of residents who have put solar panels on, and there have been millions and millions and millions of these sold in Europe without any apparent problem.
And that was an interesting thing that I thought that you brought up too, to Tommy D on his podcast, was that there's been no incidents of death or injury on these EBSE, whether it's reverse backfed or whatever, because of that digital handshake and all those other safety things that you mentioned. And I just don't think that they took that very seriously as far as trying to make this a little bit of an exception. And that's a really good example with this solar. I've never even heard of this, and that's really cool. So you're saying that essentially they don't have to have like an electrician come out and rewire their panel or anything. They just plug it into a receptacle on the exterior receptacle.
Yeah, exactly. So most porches have an outlet.
For the national.
Oh, excuse me. Let's be nice and precise, especially with the comments in the chat. Most balconies have a receptacle and an outlet, or an outlet then a receptacle. And the idea in balcony solar is that you hang your panels there, and then you run the cord to the receptacle that's already on your balcony.
That's installed in an outlet.
You begin the receptacle installed in an outlet, and it backfeeds power, thus reducing the amount of power that you're billed from your utility company.
Receptacle
and that's as simple as
outlet.
it is.
Yes.
Receptacle outlet. The receptacle is the device that goes into the outlet as a receptacle outlet.
True.
Further
100%.
definition.
Yeah. So it's kind of an interesting argument that we've had, Bryce, because I actually submitted a lot of public inputs for 2026 just to kind of be funny, I guess. But I was interested to see what they would respond. And I did one for 210.8D, and I proposed that they delete branch circuit. So they say that GFCI protections for branch circuit or outlet. And I said, why do you say branch circuit and outlet? Just delete branch circuit and say GFCI protection required for outlets. That's it. That's all they have to say. They don't have to say branch circuits and outlets, because that indicates there's two types of circuits. There's circuits that connect to branch circuit, or branch circuits that connect directly to utilization equipment, and branch circuits that connect to outlets. And they rejected my proposal and said that it would be too confusing. So I guess we just keep saying it like that, you know? But,
yeah, well, whatever the lingo is. But if you're interested in EV fire safety, then there's this great website from Australia, evfiresafe.com, where they have gone through reams and reams of safety data. This was done in conjunction with their EMS and fire folks in order to understand what these risks are and what the experience is. And they can find, and I can find, no electrocutions associated with EVSE. So if you wanted to substantiate that there was a problem that needed to be solved, that's hard to do, because the UL standard for EVSE has worked quite well for a decade or so, with many millions of units installed worldwide. So evfiresafe.com, reams of data and information for firefighters on how they have to approach a battery fire. Now, even those battery fires may change. China has just announced that as of about a year and a half from now, any EV sold in fire in China has to have a self-extinguishing battery.
Okay.
So that battery can still catch fire because it's got material, but it would be like a wood treated with some sort of fire retardant. It'll kind of smolder or whatever, but it'll have to self-extinguish. And you can imagine that a year or so after it's common in China, that it might make its way to the United States. So that's interesting too.
That's cool. Yeah. So what is, like, as far as the National Electric Code, I don't see them really having much requirements for like the actual. So I think I see what your point was when you were saying that I wasn't really talking about the fire part of it. Like the National Electric Code, when I said that about the dealership saying don't park in your garage, that specific model might not have like this kind of thing, but I don't really see that getting addressed on the National Electric Code. I know you were talking to me about emergency disconnect and saying that that would be kind of impossible to comply with. I could kind of see your point if you had like a multi-family with like multiple chargers or multiple units.
Yeah, indeed. If the problem is that the new proposed standard for emergency disconnects was copied from the fuel gas industry. It's
Okay.
the same button that you press to turn off the pumps at a gasoline station. And the idea is
Okay.
to move it over to the EV. A couple of problems with that. One problem is that if you press that button, you're dumping 1.5 megawatts. You're dumping a
Wow.
lot of electricity. You're shunting a huge load. And that's
Okay.
really bad for the grid and arc flash and all that. So that's a worry. But that exact same regulation is then applied to apartment garages where we have posts and columns and things like that. And so to try to arrange a set of disconnects that are visible from each EV charging station becomes this monkey puzzle where, oh, I put that one there, but now it blocks the other one. And you end up with a really confusing situation where you have 30 chargers and 30 disconnects, and they're all 10 feet away from their respective car. And you end up with a whole lot more electrical equipment in the garage that can be damaged. And
Right.
frankly, people pull switches. In our area, it's homeless people. In other areas, it's kids looking for some sort of thrill, or maybe
Right.
exes getting upset with somebody. In apartment world, we normally want to put all of the electrical controls in a locked equipment room that no one can touch at all without calling the supervisor. And now we're being
Okay.
asked for GFCI devices that the driver needs to reset, and these e-stop or emergency stop buttons that are in the tenant space and touchable by anybody. And so sometimes you need to look at the, how big a problem did you solve and how big a problem did you create? So it's my assertion, and the reason that I filed a CAM on that subject, or a NITMAM, was that I felt that the problem that was created was better and bigger than the problem that was solved.
I
I'm
like
wondering,
that.
you say e-stop button. It, isn't an e-stop button usually related to a relay contact that would de-energize the relay that's got the contact in place? I don't understand how you're dumping a whole bunch of energy onto the grid if you use an e-stop button. And then
Well,
and then another point is, why can't we just put an on and off switch on it? Use an on and off switch. So
Yeah, I kind of see what he's saying, David, because essentially what you have is a bunch of single pole switches. But if you use that for like one single pole switch, you have a rating that could be potentially pretty high on that single pole switch that you're using. You're dumping,
well,
let's just say 50 amps. You know, you're
okay.
dumping 50 amps, and that's like a pretty heavy inrush. I kind of see what he's saying on that.
All right. Well, so
Oh, we got
it,
Daniel. What's up,
it,
Daniel?
it would be
Daniel's up in the house.
it
Welcome in,
would be a
Daniel.
switch that would be rated for the current. So I mean,
Yeah,
oh yeah,
but
it's a switch that's rated for the current. This is a level 2 installation where the local city requires an emergency shutoff for the electric car chargers. And so these control the ones in the background. So there's 2 in the background and there's 2 shutoffs here. And the questions are, when you need, this doesn't scale that well, because by the time you fill this parking garage with electric vehicle chargers, you're also filling it with these shutoffs, and it's going to be very hard to figure out which shutoff goes with which charger. And
Right.
again, we have a vandalism problem where people will come and turn this off just because. And now you have to go and hunt down the building supervisor or the parking lot supervisor at 2 a.m. in order to get the thing turned back on. I mean,
Right.
I'm assuming that most people don't feel comfortable turning an emergency shutoff back on. I mean, I would, but I'm like that.
yeah. Yeah,
Yeah.
I can see that point, no doubt.
It actually looks like it makes the install a little bit more expensive too.
Oh yeah, definitely. It about doubles the cost because the EVSE, well, I'm doing low power L2s that are cheaper than what they're showing, but it doubles my cost when I'm providing a $200 EVSE with around $500 worth of conduit and shutoff switch, not to mention install costs. Absolutely.
Yeah, and like Jeremy saying that nobody's going around, hitting emergency shop. Like maybe we just need to make a law that they can't shut them off. Maybe that'll work. I don't know.
Yeah. Okay.
But
Good luck with that.
yeah.
So, on the other hand,
Jeremy, hush
this
up.
is what we got now for a Tesla supercharger station. And if I'm an emergency responder, well, it does say that the main disconnect for the Tesla supercharger EV1 is inside this cabinet. I don't know. If I'm there with the emergency responders and I'm asked to shut off that station, I mean, I can cut those locks, but I'm not sure that I want to open that cabinet.
True.
There's a lot of power going on there. So that's a 277 40 volt, 3-phase, 4-wire, 4,000 amp panel. And I'm being asked to cut those locks and open up that station in order to see I don't know what. And I've seen enough arc flash videos and seen enough arc flash to really be concerned about that. So I think this is
Yeah.
pretty broken. I think that there needs to be something more like a break glass here. And then you go into some little area that has only the buttons that you need to operate. And it looks sort of inherently safe. Because I don't want to be inside this cabinet unless it's on fire.
Yeah, it would be some sort of a low voltage, or a low
shunt
current. It would be a control circuit for a relay.
Yeah, it's a shunt
for a
trip.
contactor.
So what? So let me just ask you quickly, Bryce. So what if 62554 passes as is? Would that cabinet that you were just picturing, would that require a GFCI main?
Yes. So that's why Tesla is opposing the 625.54 because they don't want to do that. And especially for DC stations, it makes no sense from a personnel protective point of view because the GFCI can't work past the AC to DC conversion. And then if the e-stop requirement goes, then they can't use this method of the cabinet anymore. And I'll agree. I think I made it clear why I don't think this is a good method. But I think that the current e-stop language has a bunch of problems. The biggest one from my point of view is that it creates an additional hazard because it requires manual reset. So after somebody presses the button and shunts the entire EV station, now somebody else has to get in a truck and drive to the station to turn it back on. And in the meantime, somebody could have run out of electrons. They could be without air conditioning. They could be encouraged to try to reach another charging station that's a little too far away and end up stuck in a lane, basically running out of gas. So there is a downside to having an e-stop button that A, anybody can push, and B, requires manual reset, manual intervention by the charging company in order to get it back online. And I think we need to weigh those two risks. What's the risk? What number of people will be stranded or even killed by a heat wave when their car dies versus what's the amount of training that's needed for fire departments in order to interact with these pieces of equipment. And I don't promise to have all the answers, but as a representative of the EV industry, so to speak, I'm concerned that the e-stop requirement will reduce reliability and create hazards, even as it does something for fire or EMS response.
So, question for you: is there any chance of arguing with Code Making Panel 12, saying that this is not connected to an outlet that the EVSE connects to? That it's not a permanently installed outlet?
Well, the word outlet is messy. When I posted once on the Mike Holt forum with a diagram, and I said, could you point me to the outlet in this EVSE? I got the diagram somewhere. People had different opinions about where the outlet was. So is the outlet the place where the cord plugs into the car? Is the outlet the output of the EVSE? Is it the input of the EVSE? It's a little unclear. I tend to think the outlet in that case is where the EVSE connects to the branch circuit wiring, but others feel that the outlet is where the utilization equipment connects to the branch circuit, which is the car. And this comes from the fact that an EVSE is not really a piece of equipment. It's a fancy GFCI. It's a GFCI with one additional trick. Well, two additional tricks. First additional trick is it defaults to off. And second additional trick is that it communicates back and forth with the car. It is a GFCI in every other respect. It could probably be certified as a GFCI if it met the 5 milliamp trip level. So it's a little unclear where the outlet is. And that's what some of the wording in Article 625 was meant to clear up. Or it wasn't meant to clear it up, it was meant to just impose the rule that says you have to use a GFCI with an EVSE. And it sort of bypassed the question of where the outlet is.
Yeah, I've been actually, and David could verify this, I've been like looking for somebody to explain to me where the location is, because they've never gave me a location ever. They just said, just put it on GFCI, we don't care where it is. Mike Holt says it's at like the load side terminals at the disconnect, which I disagree with. What is it, a disconnect outlet? You know, that doesn't make sense. I actually agree with the people that say if they're going to use the terminology that's going through, it would actually be at the car, because the where you plug it in would be the outlet, and the car would actually be your utilization equipment. But that's the reason why I think it's in special equipment in 625, because it doesn't follow the same kind of physics as all the other style of branch circuits, you know. So they had to have its own section of 625. It's different, you know. It's not the same. You can't just say it's an appliance. You can't just say it's a motor, you know. It's totally a different piece of equipment. So I was actually curious, is there a way that you could collaborate possibly with Tesla or with some of these other EVSE manufacturers and qualify this equipment as a SP GFCI and comply with code?
Well, possibly, though. The issue comes back again to that threshold. If the special purpose GFCI is allowed to use 20, 30, 50, or basically like 0.1% of the charging current, then that might work. So that if we're charging a semi, we can set the threshold much, much higher than if we're charging a Prius. Then that could work. So again, another question is whether this is the proper purview of the National Electric Code, because we have a whole SAE and UL standards body that is charged with doing exactly this, which is personnel protection for electric vehicle charging. Can we just adopt their work? Do we have to redo that work within the National Electric Code?
Gotcha. Yeah, and one of the big things that I've kind of been following with this whole thing is the reason that all these people at NFPA are against, let's just say you call this big white box, let's just say you call it a GFCI, right? You say, hey, guess what, guys, this is a GFCI, it's good to go, right? The reason they say it's not a GFCI is because it's not 4 to 6 milliamps, which I think is unguided. I think it's incorrectly unguided. I think that that is the let go threshold. So I think you have to kind of have some path, and a lot of all of this stuff that they're basing this off of, and I know you're putting up another illustration. I'm not trying to interrupt your presentation, but I just think that is kind of misguided a little bit. Was kind of what I was going for.
Yeah, I have a paper that someone else wrote called "Many Cooks in the Kitchen," which is talking about all of the different agencies that regulate EVSE in somewhat overlapping and somewhat contradictory ways. So we have an EV standard, ANSI UL 2594, that has worked super well for decades. And if there's a problem with the personnel protection, if there's a flaw, if there's anyone who's being injured or risked or receiving a shock or anything, any evidence at all that it is not working well, then maybe the proper place to fix that is within UL 2594, rather than trying to glom another standard onto it that's not coordinated with it.
Right. I agree with that. And to me, it just blew me away because I kind of tried to shed a little bit of I just tried to kind of shed a little bit of the correlation between the EVSE and 210.8F, and I feel that I just never really agreed with 210.8F. I just felt like it was kind of one of those things that we've had this hardwired equipment for all these years, and this one, what they call the perfect storm. I actually have audio of so Nihad El Sharif, I know you were talking with Tommy and Nihad. Nihad El Sharif was the one that actually submitted the public input for 210.8F. Would you like to hear that audio?
Sure, let's hear that audio, and then I want to show you a death that might have been caused by 210.8F.
And I want to just give you guys the advance. I was just trying to practice on my new 12-string a little bit, so I threw a little bit of my new 12-string acoustic in here. Like, it might be a little too loud too, but we'll see.
So, and Willie's saying, did the task group investigate EVSE? Now, the EVSE GFCI requirement is actually not a part of our work.
But my understanding is the charging,
And then,
any charger that's your listed would have personal protection. The
Right.
CCID 5 or CCID 3.
Right.
So,
right, and then Willie is saying, I think on that case that you were talking about, he says, did the circuit have an EGC? And I don't know the answer to that. I think there was a problem with the equipment grounding conductor
I think
on it.
if I remember correctly, that the details, I can share the details for those. Yeah, I happened to be about to just like a home conference like this wasn't PCIC, another conference, walk into a room for a presentation. The author was talking, or presenter was talking about something completely different, had nothing to do with GFCIs, but he is a forensic engineer in Chicago, and he happened to be the individual who went and investigated this case. And he mentioned that we were between the first draft and second draft during the public comment stage. And I went to talk to him after his presentation and said, hey, I think his name was Tom too. Can I, would you be okay? Like I introduced myself, and I think we should work on fixing this problem so that we don't need to lose another life. This was sad. This way should have been 20 some years, almost 30 years now.
So that was the one thing that I kind of had a problem with, Bryce, was this happened in 2007. So they went and submitted this in 2020. So you're saying in 2008 they didn't do anything, 2011 they didn't do anything, 2014 they didn't do anything, 2017 they didn't do anything. Now all of a sudden in 2020 it's this big hazard. So that was kind of my problem a little bit with it too. That I'm like, okay, now you guys just snap to action like 5 cycles later. So I think it's interesting to hear kind of this like directly from Nihad because he's the one that submitted it. So I'll keep
He
going.
made it, right? I think he was 10 or 7 years old when he lost his life. So I asked the presenter if he would be willing to share the details with me because he was just talking like generic. And he was nice enough to go first got the permission from the lawyers and from the family of that kid, and he told me that they were waiting, and the message was gonna really powerful. They want this to change so that this, saves lives and that no one else would have to go through what they have gone through because of losing their child. And I told him when this happened, the phone was updated, and he told me that they were happy that that there was something good came out of this tragedy. So he shared with me the pictures and the whole story. I believe it was some problem with the unit, and then the maintenance guy came and they miswired the unit, and there was some issues with the unit, and then it failed. So like that's like a perfect storm kind of picture.
Yeah.
Like and this would get us to the argument. What if the person?
So stop a moment there. So they miswired the unit, and my basic problem with using GFCI as the safety tool is you can miswire the unit. And one way that you can miswire the unit is by leaving the GFCI out and not grounding it. And you can create the same hazard. So we create this code world where we think that we've solved the problem by adding this GFCI requirement, but we didn't talk to all of the handymen and the untrained electricians with quotes who actually do it. And I have an example of that from Florida. It's much more modern. So this was in 2023. And it's an incident report from Jupiter Police Department in Florida. And the clue is that it was breaker number 12 in the equipment vault with a handyman. And what happened here is that they had a pool lighting controller and a fountain. And at some point, the handyman took the GFCI out and put a regular breaker in instead. Just like the old Edison-based fuses. You just unscrew the 15 and put in a 30 or a penny or whatever you want. And that's what happened. And therefore, there were other failures involved. In the weeks before, people had been reporting getting a tingling sensation when they were sitting on around the fountain, and management ignored it. But some kids went and played in the fountain. It was a water feature, not a play yard, so they shouldn't have been in there anyway. But then their father went in, and I think he died, and the kids were okay. But this was caused by depending on the GFCI, as opposed to, here we go. So here's your old fuse box where you can take out the blue fuse, which I think is a 15, and put in a 20 because it was blowing. Now we have the same thing. You can pull out the old GFCI and put in something that actually works. But imagine instead if that pool lighting controller was required to have been listed, designed much like an EVSE, where it has all of the current protection built in a way that can't be removed without disabling its function. So build your pool controllers like an EVSE. And then when there's a fault, you can communicate, put up a light that says what the problem is, refuse to send any more current to the pool, or make a smart decision in the case of it's something like a sump pump, that maybe there's two safety hazards. There's an electrical safety hazard, and there's the risk of the building flooding, which can create mold or other problems. And maybe you have an alarm, like a little voice says, stay away from this equipment, stay away from this equipment. Or operating in an unsafe condition, or there's a big red light that says, hey, I need to operate now, even though there's this electrical fault. At the very least, with our smart devices, it can communicate that fault, but it can't do that if it's shut off by an upstream GFCI. Same thing with the EVSE. If the upstream GFCI shuts it off, it's just dead. If its internal personnel protection activates, then it can shut off, communicate that fault, log that fault, and in the EVSE standard, there's actually a retry mechanism. And that was put in with the thought that when charging a vehicle in the rain or in snow, you may have a ground fault condition that literally goes away. And I've done this charging my EV in the snow, where I drop the damn connector and it fills up with snow, and I'm sitting there tapping all of the snow out, and I get most of the snow out, and then I plug it in. And have I created a short GFCI condition? Yes. The EVSE shuts off, and then a couple of seconds later, it realizes that the condition has cleared, and it starts going again. At no point was I electrocuted. One of the cool things about EVSE is that unlike our NEMA 1450 connector, where if I grab it, I'm probably touching hot. We've got ground, neutral, and hot. And right here where I want to grab this thing, I'm touching hot if I'm not careful.
Right.
Well, that's not
Right.
true of the J1772 or Tesla connector. A, they're finger safe. You can't get your finger down to the connector. And B, they're off by default. So I pull
True.
that off the wall, and it's not like I'm pulling a giant power cord. I'm pulling something that's off and electrically safe. And until those,
True.
the computer in the car and the computer in the EVSE communicate, it's going to stay off. So that
True.
worked really well. And if the same technology had been used on that pool lighting controller in Florida, that dad wouldn't be dead.
Wow. That's crazy. There was actually a similar incident in Baltimore like that with a kid that got injured pretty bad. And, to me personally, I agree with you. The GFCI does not prevent electrical shock. All it does is reduce the duration of the event. And I feel that you're correct when you're showing that cord. All that 4 to 6 milliamps does is allow your fingers to release from those prongs faster.
Yeah. And then, perhaps in the case of, say, a sump pump that has a GFCI thing, maybe in 15 minutes, if there was a person there, it's worth retrying. That could have been a transient, just like in the EVSE case. And
Right.
can you determine it's a transient? And if there's been somebody who's been, once you turn off the power, if you've got an electric shot and you're stuck to it, and there's a second person in the room, we all know from our electrical training what to do. You block the guy. But if you're the only person there and you're being shocked and you're stuck on it, and now the automatic system turns off the power, you have the opportunity to release.
True.
So we have had deaths where people were repairing equipment and stuck their hand into the dishwasher, which was powered on, or into the microwave oven that was powered on. And if we were able to build residual current detection into those devices, so the wires come into the device and hit a junction box, and then everything after that point is behind that residual current detection, then we could save those people's lives. So even if they went and worked on their dishwasher and stuck their hand up in there and it got stuck, the residual current detection would shut off, and we'd have a safer situation than our present situation where there may or may not be a GFCI breaker back at the panel.
True. Yeah, and that was kind of, I really loved talking with you. I told you right away when we were talking on My Cult Forum that we need to have you on again because it's really awesome. I love talking about this. There's so many people that want to argue about this. And one of my points that I wanted to make too when it comes to 62554 is that they are pushing an expansion of a device that, for one, hasn't been tested with this equipment, for one, and for two, it's based on nothing. It's based on no technical merit, as me and King James have been known to talk about this a lot, that all of this has not been based on technical merit. Like if you have a body count and you have people that are being injured from this equipment, yeah, by all means push it, but it just, to me, I don't see why. I don't understand why. It doesn't make sense to me.
So in the U.S., we have this National Electronic Injury Surveillance System, the NEISS. And this takes data from a lot of places, including hospital records and actually searches of news reports for things that never appear or were never actually reported. And it collects all of these data for the last 45 years. So we have a database that can tell us and can be used in order to understand where the real risks are. And having analyzed this data, the real risk is, it's not real surprising. There's, a good third of these are self-caused injuries. It's the people who opened up their microwave oven. A fair number is construction workers who have cut the ground prong off their 3-prong cord and then used them outside in the rain. Some of them are physical. So somebody's carrying a big aluminum ladder and they hit some power lines that aren't insulated. But the point is that if you want a data-based approach and understand where the real injuries are occurring, NEISS and the equivalent in the fire world are good places to go. Now, there's a frustration with these, particularly the fire one, that's called NFIRS. They report it as an electrical fire, but there is no current requirement that they say take a picture of the electrical panel or tell us what brand of breaker was involved or anything. So you end up with these reports and you read them and you go, okay, well, this could have been that, the other thing. It could have been 10 or 15 things. But if you showed me a picture of that electrical panel, a high resolution picture, I'd have a really good chance of understanding what's going on with that panel. I could see a loose neutral, I could see double taps, I could see burned conductors. There's a bunch of stuff that I could see from a photograph that the firefighter isn't necessarily going to see when they're on scene. They categorized it as an electrical fire, and I'd like to take a look at the data.
True. I mean, how does it feel to you from actually seeing it from a standpoint from like code making panel 2, where they're like, oh yeah, the maintenance guy miswired it and there was no equipment ground and all these different things. I mean, who knows the age of the unit? Like, I saw the picture, like that unit could have been 10 years old, so the story is that I heard, like, I've investigated this quite a bit. The story that I heard, it's actually kind of like, it's tragic that the kid lost his life, but funny from it being like a kind of like a run-down neighborhood kind of. So I guess what happened was it was like somebody stole their condenser and it was like some kind of thing, and so then somebody was moving into the house, so they had the maintenance guy just go hobble up this old unit to get it running and everything, and it was supposed to be kind of like on a temporary basis, just till they get the new unit or whatever. So it was kind of just a hobbled up thing that they did. Well, they're trying to base new code based on that. That's where I have the problem with is like, okay, so somebody went and committed a code violation, so now we're gonna add stuff to the code. To me it just doesn't make sense.
Well, it also doesn't make sense because it doesn't solve the problem. I can guarantee you that had the GFCI requirement been in the National Electric Code on the day when that HVAC unit was rewired, that guy,
they would have bypassed it.
Let's call him Vinny. My cousin Vinny or whatever. Let's call him Vinny for the moment. Vinny
100%.
was not going to spend an extra 10 seconds in order to hook it up. He would have bypassed it if it was already there.
True.
We already know that he was using, you said, some form of liquid tight or something like that didn't inherently conduct enough ground current. So it wasn't going to be wired anyway.
So liquid tie is permitted to be used as an equipment grounding conductor, but not at lengths of 15 to 20 feet and not at that ampacity. So that was already a code violation. And what we've always said is they say, oh, well, if this unit would have been on GFCI, Bontrell Pergo would still be alive. And the actual reality of it is if, the maintenance man just spent an extra 10 cents or $5, whatever, I couldn't even put a money value on it, and put a number 10 equipment ground in there, then he'd still be alive too.
Yep, but I have an even better way. So imagine if every HVAC unit, outdoor HVAC unit, did what EVSE already do, which is check the integrity of the ground.
True.
So what if that equipment, now we don't want to make it not work, because again, we could kill somebody by having the HVAC unit off during a heat wave.
True.
But it could be throwing some form of trouble code, or it could operate at 50% of its value, something that'll really get people's attention. So if the kind of safety checks that are already built into EVSE were built into microwave ovens, dishwashers, HVAC units, then that's non-bypassable. So Vinny got an old unit, but eventually all those old units will die. And so if this personnel protection is built into these units, Vinny can't bypass it. The Florida death, if that pool controller had the residual current protection built into the pool lighting controller, then that maintenance guy could not have bypassed it. So I think we're much, much better off putting our smarts into the devices in a way that you can't disable it without disabling the function of the device.
Yeah, and I 100% agree with you. And I actually, what I really agree with is what has kind of went through in the last, I would say since 2020, in the last code cycles, is the code making panels feel they need to control the branch circuit. And so it's been a problem in appliances in 422. It's been a problem in all these different ones, and the AHJ has to make that decision to allow us to just put a regular thermal mag in there because it's not compatible. We actually did a high-rise downtown, and there was so many things that weren't compatible with combination AFCI, GFCI devices. Fridges was a big thing. There's LED drivers that aren't compatible. There's, like I was talking about earlier, freak drives that aren't compatible. There was ovens. Actually, I don't know if David knows about this, but like cooktops and ovens has actually been removed from 210.8. Now they actually took it out of there. So that's one of the things that got taken out of 210.8D. So there's some good progress that we have with like trying to actually address it, but just that arrogance of we have to protect the branch circuit, and they don't care if there's two methods of personnel protection. So I find that interesting that you're on the same page as me. Let's just keep what we've been doing for all these years, that things work. And then let's put pressure on these manufacturers to provide personnel protection at the equipment and leave the branch circuit alone.
Yeah, I think we should leave the branch circuit alone in most cases. Here's an emergency TIA to the Massachusetts Electric Code. And the way this happened is that they did this big program where they bought a whole bunch of brand new stoves for people who were low income and installed the stoves. And they kept having GFCI trip problems, and the people couldn't cook. So you thought you were helping somebody who was low income, and you ended up hurting them by changing their stove out, and they couldn't go back. They couldn't go back to the old stove because they took the old stove away and threw it out, and they put the new ones in. So what they did is it's a new rule that essentially says if your equipment is on a dedicated branch circuit and it's incompatible with GFCI, you can take the GFCI out.
And I don't know if you know this, but I actually submitted a public input on that for 210.8A, and I submitted a public input to just make everything like that. So if you have some kind of paperwork that says this is listed and labeled not compatible with the Class A device, then the manufacturer is going to assume that liability and take that compatibility and say this has not been injuring people. The reason that I based that off of was some of the research that you had posted up earlier with the consumer data information, and refrigerators and cord connected AC window units are the two lowest injury appliances in a dwelling unit. And a lot of the fridges are coming out saying they're not compatible with Class A device. And so that's why I submitted that as like a exception, because if you have this refrigerator and it says, hey, this has been listed, labeled like, so just to kind of go back with the whole 210.8F thing. So the frame of the AC unit got energized. And so they wanted to say, okay, so the frame of the AC unit got energized and that's how the death occurred. Well, now a lot of these appliance manufacturers are not even making their equipment, they're not even using metal anymore. They're making them out of plastic, they're making them out of fiberglass, they're making them out of all this different stuff that's insulated and can't become energized. So I found that interesting too, as part of that exception where you just removed the whole hazard of what they're trying to prevent on the branch circuit.
Oh.
So I don't know if you encountered any of that either, Bryce, but that was kind of what I wanted to bring up from
Yeah,
a consumer.
indeed.
Like this happened on an AC condenser, and you go look at a lot of the AC condensers now; they're made out of plastic.
Yep. In the tool world, we'd be calling those double insulated, and allowing them just to have a 2-wire cord rather than a 3-wire cord. Now, I've been on a lot of construction sites, and I would say that it is more rare than not to find extension cords used on job sites that have that third pin. People pull the third pin out. And so I would rather be using a 2-wire double insulated tool than depending on that ground being continuous back to the circuit breaker.
True, and we've actually found before, David probably knows a little bit about this if you've dealt with any of the hospitals, they put the receptacles upside down, and then what happens is that weight of the cord goes on that ground pin, and in the hospitals for some reason we always have ground pins getting popped out because all that weight's just hanging on that ground pin, and then you're just losing ground pins all the time. I think we had like 4 cords in like a week that lost that ground pin. Oh, that's awesome. Are you showing the code cycle there?
Yeah, before we run out of time here, the code cycle for 2026 is moving along. And basically the last big event is the technical meeting, June 15th to 20th. And the CAMs, the proposed essentially appeals, will be heard at that meeting. CAMs rarely succeed. But after that, in an appeal window, it'll be 20-day appeal window, there'll be a final council action expected in fall of 2025. Now, the EV industry submitted a whole pile of CAMs, kind of a shocking number. The default position of most members is to vote no on a CAM, but there's quite a few of them here on various topics, most of which we've touched on. I'll touch on one more in just a second. Unfortunately, Ryan Jackson and I both submitted NITMAMs that became approved CAMs, and we both support each other's positions, but the CAMs are mutually exclusive. It really sucks. So I started out and I wanted to use this connector for EVSE right here. So it's a 32 amp finger safe connector that I can't touch the pins of, and it goes in and it's awful nice. And the problem is that it's locking. Makes a nice click sound when I lock it. And I didn't care that it was locking, but I cared that it was finger safe. And I'm not allowed to use this connector because 625.44 says that if you're going to charge an EV, it has to be with a non-locking connector. And I'm told that the reason for that is that they were worried that someone would drive away with their EVSE plugged in. But I'm telling you, if you drive away with your right angle NEMA 1450 connected to your car, it's ripping the outlet right off your wall.
True.
It's just, so I think that it's obsolescent. The problem is that Ryan also has a good point that there's a technical flaw in the substantiation for the word listed, and his CAM fixes that. My CAM allows non-locking connectors to be used, but the way that the CAM process works is they can't both win.
Right.
They ask for mutually incompatible changes.
What I heard now, what I heard is that the code is going to require the receptacles that the vehicle chargers plug into to be listed for EV charging.
Yeah.
That there is no standard for it.
That is Ryan Jackson's NITMAM and CAM. And the problem is that the way the NITMAM CAM process works is if his passes, then the word non-locking goes back in. And if mine passes, then the text that he was worried about goes back in. Now, I'm hoping that if both of them pass, that there is some reconciliation mechanism that can realize that these two CAMs aren't really in conflict and accept them both. But as written,
Right.
they're mutually incompatible. I'm not meaning that Ryan has to vote no on mine, even though he supports it, and I have to vote no on his, even though I support his.
And I'm in TerraView trying to find that change, but I can't find it.
Well, look at the CAM report. It's there.
Okay, I'm not in the CAM report, so I'm in the second draft right now. So
Right.
Okay, so it's after the second draft then, right?
Well, remember that in the NITMAM CAM process, you're allowed to take any public comment that was made through the entire cycle and say, hey, wait a minute, you should have really adopted that. So you actually have to go back to a PC. In my case, I go back to the PC by Brian Seymour, and he's the one who has the electric airplanes for the military. And what they want to do is they want to put a outlet and receptacle at every gate that's locking and waterproof. And then when an aircraft comes into that particular gate, then they wheel over or drive over a portable DC fast charger. So it's on wheels. And then they want to plug into the branch circuit and begin charging the aircraft. And so they have, I think, a pretty compelling use case for a waterproof locking connector, but they're not allowed to use it under the NEC. And so I'm actually asking why the NEC is restricting connector types at all. That doesn't seem to be a function of the National Electric Code. That's a function of the market. If the market wants to buy a listed green connector that's waterproof and sings howdy doody, I don't understand why the market can't create that connector.
Or even standardized.
Standardized or not. I'm not sure that the National Electric Code should tell us. If it's listed for its purpose and for continuous use at the amperage given, why would the National Electric Code prohibit me from using that? That's exactly my situation here. I've got a connector that is listed, made by multiple vendors, widely used. It has decades of safety record. It's widely used. You go to a Taylor Swift concert, the roadies aren't using a NEMA connector that anyone could kick out during the show, because the show must go on. So they're using this really robust locking connector for good reason. So there is no problem with this connector. I could use it for EV charging. The only reason I can't is that my permit wouldn't be approved.
But the only thing about it being listed is that it's listed to a standard. So
yeah, I think that's all that's important.
Yes.
Oh, that's bummer, Caesar. I guess the Stars are losing. Oh, man. Man. I hate seeing the Stars lose. Sorry about
I
that.
forgot that this was half a football podcast and half an electrical podcast.
Yeah.
All right.
We joke around. So, question for you. Wouldn't Article 90 kick in since it's military? That's not actually covered by that wouldn't be in the scope because of military base?
Fine, except remember that the military flies into civilian bases as well.
Yeah, but I mean, wouldn't you use that as an argument to the code making panel to be like, hey, you're only going to apply here and there, you know, like couldn't you make this standardized to where it doesn't matter if Article 90 applies or not? Like, I guess just use it as kind of a arguing tool.
Well, my argument is that you can just, hey, you know, we're in an era of deregulation where we're supposed to be reducing government regulation. You can delete an entire section of the National Electric Code, and it will create no safety problem. So
Sure.
just delete the whole thing. You're done.
I agree, 100%.
Ryan
Yeah,
would be
I
happy
mean-
as well.
Yeah, right.
Yeah.
So all we need is that it be listed for its purpose. That means it's amperage and continuous versus not. And it's, again, where the code appears to be giving a solution for a problem, but the solution doesn't solve the problem. We do have a problem in that Leviton released millions and millions of NEMA 1450 outlets, and they were sold at big box stores and everywhere and installed everywhere. And it turns out that they were not robust enough for continuous duty EV charging. They melt. And you don't have to look very hard on the internet to find some pictures of some melted Leviton outlets. Now, it could be that those people didn't properly torque them, but they're kind of cheesy outlets, and fine. So we can't go and remark those outlets now. It's too late. They're already out there.
True.
But there's an education thing. If you go onto any of the Reddit forums and you ask for advice on how to install an EVSE, people will come back and say, wait a minute, take a picture of your outlet. And they'll tell you if you've got one of those Levitons. And they'll advise you that you should be using those at 24 amps or less, or replacing it.
If
So,
I may, the receptacle outlet.
Yeah, not
Oh, sorry.
Yeah.
Come on, that's the inspector and plans examiner in me.
Yeah, sorry.
There you
And I'm geeky enough that if I wasn't all high on being on your podcast, I would correct the next person.
Yeah,
Dude, I am so happy to have both you guys on here, because like David's always coming on here, and like he's always been loyal to this podcast. It's really cool to have him be able to ask you questions directly and just kind of pick your brain on what you think about this new cycle coming through. And I think for me, the biggest thing comes down to 210.8F, with all the inconsistencies of that, and just the fact that these local jurisdictions, I don't know if they adopted it there in Florida, David, 210.8F. Here in Colorado, basically, it's just like it never existed. They basically just deleted it, and so it was deleted without substantiation, or without replacement, or without any kind of substitution, and it was basically because of they had no technical merit to make that change in the first place.
Yeah, indeed. So in my area likes adopting rules. So it's adopted 210.8F, and we are paying the price for it regularly. And I wanted to respond to Jeremy Weed in the chat here. We live in different areas, and in my area, yes, people go and shut off buttons and press buttons and do that. Not every time, not all the time, not every night, but enough that if somebody suggested that all gasoline cars should come with a little button that you can press that turns off the fuel between the gas tank and the engine. And not only that, but that button could be pressed from the apartment parking garage. I'm not sure a lot of people would be very happy with that. And that's what you're doing to our electric cars. We need to charge. We need to charge overnight. We generally need to charge for a couple of hours overnight. And we're not necessarily going to notice that at 10 p.m. some random homeless dude came by and flipped our buttons, or that some kid was just messing with it. And again, when I'm designing apartment circuits, I want to hide all of that electric stuff in a locked equipment room. I don't want it accessible to anybody.
Yeah, and I 100% agree. I'm an electrician downtown Denver here in Denver. And I had one time I was doing a service call, and I realized that their equipment room wasn't locked. And I was like, what are you guys doing? You're downtown Denver, and this room's open. I was like, you guys gotta make sure this locks. And they were like, whatever, dude, whatever, And so I'm on 24-hour emergency service. Next thing you know, I didn't even know. It was like 2 o'clock in the morning, 2:30 in the morning. I get this call. They're like, we're out of power. And so I didn't know what was up. I didn't even call anybody. I just got in my van. I hauled ass down there. And somebody had come in there drunk after the bar or something and pulled the 1200 amp disconnect and shut the whole place down, And I was like, now you see why you need to have this door locked? And they were freaking out like the whole world was ending to them. And I'm like, so the whole world's ending at 2:30 in the morning, but you wouldn't even listen to me 3 days ago and I told you get this room locked.
Yeah.
Guess what? That room's locked now. It's ridiculous that people, especially, like, I don't know if you know this, Bryce, but you don't make it as a podcast unless you have your first troll, and that's Weed Man. He's just always trolling in there, so,
Yeah, well,
I appreciate
whatever.
you answering his question.
And that room is readily accessible per the definition.
Yep, it's readily accessible. That room is readily accessible to the fire department, and they want to go in there anyway. And all the fire people I talked to,
Chop.
well, they're going to be smart about it. So if they've got a fire that they think is contained to one unit, they're going to shut off that unit so that their elevators and their common area lights still work. So really, if you want to make something that'll really make the firefighters happy, require that anytime you pull a building permit for a multifamily building for electrical, that
So
before
I
you get that
actually
permit
agree
signed
with
off, you make sure that all of those breakers and switches are properly labeled.
True.
That right there.
I actually agree with Jeremy on this one. The NEC does not cover misuse of equipment. So that supports your point 100%, Bryce. Like, you cannot cover in the NEC misuse of equipment. So I know that there was some language in 210.8D to put microwaves, and I'm not sure if that's going to go through or not, but I don't think it will. I think they took microwaves out of the GFCI equation, and the reason why they put it in the first place was because people were working on their microwaves while energized. And I don't know why you would work on your microwave while energized, but that's misuse of equipment. That code can't cover that.
Yeah, and with the microwave, you're especially stupid to do that because there's a giant capacitor, and there's very high voltage on that capacitor that persists after you unplug it.
True.
So don't work on your microwave live.
100%.
Now, there's another related one. So another of my cams is on 625.4. There's a new requirement that EVSE be installed only by qualified persons. And the reason I'm against that is that I assume that after that passes, people will continue to install EVSE DIY. I don't believe that will be good enough. And I have two choices. Either they can do that against code, or they could hop on down to the building department and get a permit, install their EVSE, and have a professional inspector check it, meaning check their breaker, check their wire size, check their conduit. And if I have to choose between those two, I'm clearly choosing the second.
Yeah, and I think that could kind of go both ways. Honestly, I feel that it could be good to have some language in there, but like, it goes back to like one of my public inputs for 210.8F says when HVAC units are replaced, they need to be GFCI protected. That goes into a lot of that same thing, why I was against it, because I see people not pulling permits, not getting inspections, just like, we don't want to have to deal with that. So if we're not going to be under the radar, we'll just do it anyway, So that goes into that, why I would be against that. Like, kind of like you say, it would kind of push it more to the black market at that point.
Yeah, in my jurisdiction, my local jurisdiction, I can go down to the permit department and for a single family home, just give them some money, don't have to give them any plans, install my EVSE, and then get a professional inspection that includes a torque check on the connectors.
True.
And that to me is way better. If 625.4 passes, then my jurisdiction will have the question, what is qualified? And right now we have no method to determine if somebody is qualified so it's vague. And we have one thing, it's EVITP, evitp.org. And This is a certification course that you can take. It's online and then has a proctored exam to install EVSE. But it's way overkill for a level 2 charger at your home. This is a 20-hour
Right.
course, and it goes into all sorts of esoteric topics that just never come up in a home install. So if there were an EV-ITP Lite, say a 1-hour course with a proctored exam that made you qualified to install your own home EVSE, I'd be all for it. And I think that we should be encouraging people to be in the system, not encouraging people to go around the system. The other flaw with 625.4 is that it'll move people from installing EVSE to installing receptacle outlets instead and calling them something else. So they'll install an outlet and say, oh, this is for a new welder that I plan on buying.
Right.
And the city inspector goes and looks and says, wait a minute, I don't see any welders, but I see a new Kia EV. And they'll go, nope. That receptacle outlet is for my new welder that I'm planning to buy next month. It's
Right.
bullshit.
Yeah, I agree with that. That's a really good point. I like that. One of the big things that I've kind of been into a little bit too is when you look at the definition of qualified person in the NEC, it's not really clear. So that kind of aligns with what you're saying. Like, so qualified person per NFPA 70 would be like, okay, I took safety classes. Like it's kind of a little bit off base. It's not really directional of, okay, I'm qualified to install electrical. I took a bunch of safety classes. I know how to avoid an arc flash, So kind of the same way you're like not wanting to dive into that Tesla, load bank center. Like I 100% am with you. I'd be one of those qualified people. I'd be like, I'm not going in there. I'm not cutting those locks and de-energizing that thing under load.
Yeah, indeed.
So that comes into the qualified person part. And
yeah,
so
and who's qualified too? So I can tell you that, and qualified for what? So do I feel qualified to enter that Tesla cabinet? No, I do not. And I don't believe that, I might be qualified for one thing and another, and it's a little hard to determine. It's hard for a permit agency to determine whether I'm qualified. Am I qualified to install a home EVSE? Well, I am in California because I'm allowed to do electrical work on my own home until 625.4 passes.
True.
And am I qualified to install load management? So every time that I install load management on EVSE, which is a sort of esoteric topic, it requires a lot of setup and it uses a bunch of apps and it's kind of complicated.
Right.
I do that work, and the licensed electrician who I've hired, either a NECA contractor or a licensed electrician in the area, they don't understand that. They're not they may be qualified to run the conduit pipe and follow the National Electric Code as they know it, but they're not qualified to configure the load management system. And it's crucial that it be configured correctly, because if you configure a load management system wrong, then you start tripping breakers. Hopefully there's always an upstream overcurrent protection device ahead of every load management system. So if it screws up, you're okay electrically, but you'll create one of those situations where somebody's going to go put in a bigger breaker or something if your load management system is incorrectly configured. Most electricians, I would say, really safely are not qualified to configure a modern load management system.
I would actually agree with that. I mean, I'd call myself the exception, but I'm actually just joking. But one of the things that I kind of wanted to touch on, I know we're like running short on time. I really appreciate you hanging out with us for this amount of time. Is when you go into the National Electric Code wants you to adjust that circuit by 125%. Now, I know you mentioned that a lot of this EVSE comes with this already integrated to where the 125% is already factored in. So if we're doing this from like an installation practice out in the field, what we're doing is we're actually factoring in 125% twice. So
Yes.
we're allowing 125% to the branch circuit, and then the equipment itself is already configured to factor in 125%. I feel that that's incorrect.
Yeah,
What's your
yeah.
take on that?
Well, my specific comment there was that if a load management system is running both continuous loads and non-continuous loads, it should be allowed to supply the non-continuous loads at 100%, just like it would be if there were no load management system at all. And the cool
Okay.
thing is that the load management system, we don't have to use the approximation of continuous anymore. So the code has this concept that some loads are continuous and some loads are non-continuous. But that's just a guideline. You know, is an electric dryer continuous or not continuous? Well, at home it's not continuous, but in an apartment on Saturday morning, you might have 10 dryers and all 10 of them are running solid from 9 a.m. to noon. You know, that's
True.
a continuous load. And so the load
Yeah.
management system, because it has a timer and a clock, it can measure time. And it can say, wait a minute, this circuit that we didn't think of as continuous, say a range hood fan, is continuous by the very fact that it ran for 6 hours or 3.5
True.
hours. And what we care about is not whether it's continuous or not. The continuous knot is a proxy for heat. We care about conductors getting too hot. And the load management
True.
system is really in the catbird seat in being able to understand what is continuous and not. I would even claim, though I will get my head put on a spike in front of the NFPA hall in Las Vegas, that it should be perfectly okay to run an EVSE at 100% load for a short
Oh,
time.
dude, I 100% agree. So, like I actually experienced this when I installed one for my wife's boss. He bought a Tesla and he was plugged into like just a regular 20 amp recep in his garage, and it was GFCI protected. So I knew that there was compatibility because he said it would trip like maybe once a month or twice a month, you know. But the problem was it took him 3 days to get enough charge so he could drive it, you know. And he's like, can you just come put me a circuit in? He didn't care what ampacity, he didn't care what. I wired it like commercial. So I know I'm real, I've been doing commercial for 30 years. I was like, okay, I'm going to run 3/4 EMT in your garage. I'm going to hardwire it and you're going to have 50 amps. And I put it on a 50 amp breaker. And right away when he powered it up, it says your charging rate is 42 amps.
Yep.
So it already factored in the 125% and everything. And he was happier than a June bug. That thing charged like 8,000 times faster than it was before.
Jesus Christ.
And,
Yeah.
you know,
Yeah,
a lot of
I
these
had
people
a-
say there's a big difference between that 42 amp charging and that 48 amp charging. I didn't see it in that case.
Yeah, I had a car that I needed to get charged, and it was the middle of winter, so it was 17 degrees Fahrenheit out, and I knew I needed to get the charge, and I happened to have the app open so I could set it to whatever current I want, and it was on a 20 amp circuit. And in that particular case, I knew that I could safely raise that to whatever it was, but certainly more than that extension cord was supposed to take. And in the morning, of course, nothing was melted because it was so damn cold out. But that's a one-off situation. But the load management
Right.
system could know that, hey, wait a minute. Okay, I've got this 50 amp breaker, and I could charge at 50 amps for a good hour before these conductors even begin to heat up. And then, if it still needs charging, then I'm going to ramp down quite a bit. Or a load management system could involve thermal conductors, such as smart breakers in the future, that measure heat, which is exactly what the Tesla NACS connector does. So that one pumps way more amps than the wire size would suggest is possible. And the way it does it is with the thermal sensor in the handle. So basically, the way that Tesla charges is it pumps DC into your Tesla until the connector gets too warm, and then it backs off.
Right.
And we've got all sorts of
this-
stuff like fault managed power and all sorts of computer tricks that now we can use to take stuff that in the old days was unsafe. And we had to have this simple rule, like continuous versus non-continuous at this arbitrary time period. And
Sure.
3 hours was never magic. Like no one did a study that said 3 hours is okay and 2.5 hours is not okay. No one ever did that study. Someone
Sure.
just put their thumb down and said, oh, well, after about 3 hours, you know, all these connectors are going to be getting really toasty. But now we have computers that could measure it. And that means that
True.
on a cold day, they could charge harder, just like a Tesla will. You take a Tesla out to the middle of the desert, it's already 110, and you plug in and start to DC fast charge, and it's going to derate itself much faster than that exact same Tesla in Alaska during the winter.
True, and
But-
I did hear your comment on that when you were talking about that, and I actually thought of that because what it did when it showed me that readout in the software, it was giving me the worst case scenario.
Yeah, depending on the brand of charger that you installed, there may have been a dip switch or a rotary switch that lets you set either the breaker size or the charging amps. And it's
Yeah.
confusing because, you know, you install a 30 amp breaker and you're supposed to have the EVSE set to 24 amps. But that's a point of confusion among even electricians. It's,
I agree.
you know, is the 80% baked in or not? Does this control
No.
set the breaker size or the maximum ampacity? And I think that the vendors should make that more clear.
But
David's
are
going
all
crazy over there.
car chargers like that? You keep mentioning Tesla, which on a tangent now. We've observed installation instructions that require a certified Tesla installer to install the Tesla charger. So
I don't have a problem with that. If Tesla wants to make that rule, that's fine.
But my question is, you mentioned stuff about you're mentioning stuff about automatic shutdown and all this other kind of stuff. But and I think that you're referring to the Tesla chargers. Now, are all car chargers like that? So is that the standard?
It is certainly extremely common. The vast majority of chargers from all brands have adjustable ampacity, and it's meant to be, it's either set at installation time in hardware, like with a switch, or it's set via an app. And I'm actually, as an inspector, I'm uncomfortable with an app because I can't necessarily come along later and validate that it was set correctly.
True.
And
That's a
in
good
fact,
point.
I submitted a PC that said the following. It said that if your ampacity is adjustable, you not only have to label it, but it has to be field verifiable using no special equipment other than a smartphone. That's what I said.
I like it.
So I allowed you to use a smartphone to, like, you know, run a QR code or something. And so it has to be field verifiable with no special equipment other than a smartphone. That means no passwords, no knowledge. I can just come to it raw without the user manual and verify that it's set properly. And that's what I would demand as an inspector. So right now,
Yeah.
when I configure those systems, I show my app to the field inspector from the city, and they don't know what I'm doing. You know, it looks like the number 180 is there. They don't understand, and they can't verify it. The moment that I leave, it's a black box to them.
And then who? I mean, how can the inspector verify that it's going to stay the same way all the time?
Well, in the case of it being a rotary switch inside the unit behind screws,
True.
we already have this rule. So if you're willing to use
Yeah.
a screwdriver, you can fuck anything up.
Yep.
Okay?
You can put a penny in and screw it.
Was that the bomb?
Yeah. So that's my guideline. If you're willing to use a screwdriver, you can open it up. You could switch hot and neutral, whatever the hell you want to do. So we can't protect against that.
Yeah.
And
So So basically, my point was, David, that in this case, and you did make a good point, Bryce. When I did this, I actually set it to a 50 amp breaker, 100%, and then it said you're charging at 42. So it already adjusted the 125% inside the software. And then I closed it up. It was a rotary switch in there and everything. And then I closed it up, and then I'm taking the basically the leap of faith that nobody's gonna open that back up and change that rotary dial. But the most
I think that's
that
the
they
only
could
thing that you
change-
can do, because somebody could also open it up back up and put a different size wire in it or
Yeah.
something.
Yeah.
So this is the instruction manual from a non-Tesla, and position 2 is 16 amps maximum, meant to be used with a 20 amp circuit breaker. And then they come with a bunch of stickers that you put on the outside of the case that says that's what you set it to. I think that's pretty good. But if I'm then diagnosing a situation where it's not working right, I would love to see this little guide actually be printed inside the unit. Right there on the board.
True.
And a permanently attached label on the inside meant only for me, only for future service technicians, in order to verify what's going on. And if I see the position switches at 4, then I know it's at 30 amps. Turns out this particular model has a problem where they have a little rotary switch, and if the number isn't lined up perfectly, it defaults to 48 amps, meaning that it's actually at 2.5, because someone made a mistake. Then it defaults to 48 amps.
Wow.
It didn't quite click into the spot. And I think that's a bad thing.
Mm.
But how am I going to verify that later without having a guide that says this is what it's supposed to be set to?
True.
So that was my PC, and it was rejected very tersely by the CMP. They weren't
Wow.
interested.
Okay, and you just wanted labeling.
I wanted it to be field verifiable, and I was leaving it up to the vendor to determine how that would be done.
Hmm.
And in the appliance world, there's a plumbing code requirement when you install a water heater. You now have to put the manual in a bag and tuck it into the equipment. The service manual, all 50 pages of it, has to be left right on site, accessible to anybody who works on that equipment in the future. That would be a perfect solution for an EVSE vendor. Now, EVSE are outside, so I'm really thinking about like a little manual that's tucked inside the case, or a QR code that opens a local web connection to the device, or maybe even a sticker that you put back at the breaker panel, but I would prefer that it be on the actual piece of equipment.
Yeah, I don't see a problem with the manufacturer like providing just a sticker that you just affix to the inside of the equipment. Like, I don't see why that would be a problem. Like, that I see that being doable, but
but I want it to be verifiable so that I can come back 10 years later with no knowledge. The company's out of business, their website is down, and I want to be able to determine what the proper setting is, or maybe even change it. So let's say that the EVSE was installed, and it's installed for a 50 amp breaker, 40 amp charging, and then later I go and add a heat pump to the same house in 10 years. And it turns out that I want to starve the EVSE a little bit. I want to take that down to 30 amps so that my heat pump can work better. Why not? So, maybe I put a 50 amp EVSE in, and it turns out that like many people, my car charges by 12:30, by 1 a.m., and I'm okay with it charging by 4 a.m. So maybe I've got some better use for that electricity later, but that manufacturer is now out of business. I can no longer download their service manual.
True. I don't see why you couldn't do that with a QR code. I don't see why a QR code would like expire or anything. Like, I don't see that being an unrealistic public input.
A QR code to a local web page that's on the device would be okay. A QR code to the web So you know that a major manufacturer of EVSE went out of business. They were
Yeah.
NLX juice box, and they exited the North American market with less than a week's notice and stranded all of their consumers, and all of the fast chargers and slow chargers that used NLX products were left high and dry. Just one day,
Wow.
you couldn't access it. And that could happen to anybody. So, there are very few companies that have lasted 100 years.
Yeah.
And the ones
Sure.
who did, like AT&T, and aren't really the same company anymore.
There's
Right.
very few companies who last 50 years.
Yeah, IBM is one of the few that's actually lasted a good long time, but it's a shadow of what it used to be. And so I don't trust that, not to pick on my friend Nicholas Johnson, who started Orange Charger, but, it's an EV company, it's a startup. Most startups fail. So am I, from an electrical point of view, going to put in an Orange Charger? And now I'm working on a 50-year-old electrical panel, and I'm putting in a device that might only last 3 or 4 years, as they move on. Or maybe a new company buys them out and discontinues that product line, and you can no longer get the service manual. So I think we need to look at that much longer timescales. I work on buildings that have 100-year-old electrical systems that are still operating and fine. And there's some that were built in the 70s that use Federal Pacific that are crappy and falling apart. It's not age. So what can we do to make our installations robust enough to last for the expected period of time that they may be in service?
Yeah.
Job security.
There you go. Yeah,
Not
and
security to repair it, but we like it when it doesn't catch fire.
yeah, like that's really good, dude. I'm telling you, Bryce, dude, we have so much more to talk about in the future. Like, there's so much that we could keep talking about. We're already at like 2 hours. This has been such an awesome time for me. I'm so glad that you came and joined me. And like I say, King James kind of goes in a little bit more with the history of the code. I'm not so much like David has a lot more history of the code than me. I'm kind of more like newer code. Like, there's been times where David's called me about certain code things and I've been able to answer it. But at the same time, it's really awesome to have like knowledgeable people on this podcast. It's so much fun talking code. Like I say, I've been installing electrical in commercial for 30 years. I've rarely fail inspections. I know what the inspector's looking for. I make sure that all this stuff's complied with, but we're running into a lot of issues with 2023, 2026. We were talking about the other day, David, 2029. They're talking about adding 40 chapters to NEC and totally rearranging it. That's going to be interesting, So all this stuff is like challenges that we face in the industry. And I really appreciate having your take and your opinion on what you think, and kind of showing you some of my sound bites from some of the podcasts I've been on, asking questions. I'm not popular over there at the Mike Holt Forum with my takes on, I don't feel that there's an outlet on hardwired equipment. I've just always been like that. Maybe you could prove that the definition proves otherwise, but I just feel that the risk hazard for personnel is low. And I feel that that's been that way for all these years. I don't see why it just all of a sudden changed in 2020. So that's always been my take, and I've been trying to push that as much as possible. I know David 100% doesn't agree with me all 100%, but we agree on a lot of stuff, and it's really cool to just be able to hang out with you guys, talk code, just get our opinions out there, and have our weekly troll show up and try to say his 2 cents, which 100% I agree that the NEC does not cover misuse of equipment. That's 100%. It cannot. that would be like you saying that there has to be a code that you can't use your lawnmower as a hedge trimmer. Yeah, you can't use your lawnmower as a hedge trimmer. It doesn't need to be a code. So I'm in agreement with that. I think we can't fix stupid. So that's kind of where I'm at. And I really appreciate you joining me, Bryce. I really appreciate you joining me, David Englehart. Like I said, I wish we had more time to talk about this.
Yep.
And like I say, do you have any closing thoughts that you want to kind of go over real quick, Bryce? Before we take
Well, I'll
off?
just say thanks for the fun chat here, and I encourage everybody who is an NFPA voting member to support the CAMs here so that we can do 625 right in the next code cycle, because
I agree.
you don't get this many CAMs unless something is wrong. Sorry.
Yeah, what is your opinion on my public input? Do you think that it was really funny or just hilarious, or did it get a lot of laughs? Like, I don't know. I don't know.
Well, no, I think that your CAM was used by people who already wanted to do what you jokingly said
Okay.
in order to put it in. But frankly, if you hadn't made that input, it would have gone in a different way, I'm guessing.
I agree.
Well, I don't think the people who put it in understood how big the impact is on the reliability of the faster, heavier charging that we're just getting to. We're just getting to the point where we're charging school buses and semi-trucks.
True.
And then right at that exact point, we get this unworkable Article 625.54. So,
Oh, it's
no, not
workable. It's workable. You just have to go in there and say that is not. We don't need 2 GFCIs. All we need is one SP GFCI, and that equipment identifies as that. And I think that'll work. I think that's a good move.
yeah, well, I hope so, but at the moment, it's looking like there's not enough understanding of EVSE in order to get the right result. Well, let's hope. Anyway, thanks so much.
Well,
You have a great evening.
yeah, thank you, sir. Thank you, David. You guys have a great night. And as always, remember, make every day an easy day. We'll see you guys next week. Have a good night, people.
Good night.
Night, night.